Okay. Hello and greetings. Today I'm doing a presentation for my project for water infrastructure and resources management. The project is WRM3701 network design, the network design project. So yes, so this is okay. This study examines how the bulk water project for the Tepisa. So we're given a project in the Tepisa local municipality will be implemented according to the water service development plan. The project objective is to bring water to 4 townships. We will be examining the water supply system, making suggestions for hydraulic infrastructure design as well as for pumps, including pumping mains, bulk supply reservoirs, and bulk supply mains. This design will help to determine the following: the exact number of pumps which are needed, the storage capacity which we're going to need, head loss for components, pumping mains, and the pipe diameters, hydraulic profile for gravity mains. Determine whether pressure surge is necessary. All right. All right. This is that's my executive summary, and for my introduction, basically it's so in order for us to do that, we need to according to our correct way. So the project is basically in that. You start by opening your Ethernet. That's the website we're going to be using to do all the design. So from the Ethernet, you go and set your Ethernet. And then when you set your Ethernet, on the hydraulic page, setting flow unit on the hydraulic page, you set your flow unit to LPS and head loss to HZ. And then on the notation page, you want your node IDs and link IDs to show, so you also tick that to make sure your IDs and your node IDs and node and links show. And then you go to under the symbol page, and then you check all the boxes there to show all the symbols for your design. And then you calculate your node elevations. You have to insert elevations in all of the nodes, so you do your node elevation there, and then as you can see there on the slide, these are all the nodes elevations you're going to be using. And then we go back to your program. So in your program, this is where you are actually inserting your elevations. This is center one, as you can see, and you saw on the previous slide. Center one is actually there by demand center one. You do the same thing for every node. All those elevations you calculated, you add them on all the junctions, all the intersections and junctions. You add all your nodes. Yeah, right. After the nodes, you go to your pipe length, all the links and the pipes. You put in all the necessary information for your pipe links, all your diameter sizes and lengths and everything. You edit all there on Ethernet on the program. As you can see there, that's what you do. So you add all this information, and then Ethernet is actually this is where the time properties and Hazel-Williams equation is used. Ethernet uses an Hazel-Williams equation to determine the head loss and liters per second for the measures LPS. The cycle we're going to be using is a 72-hour cycle, that is 3 days, and the pattern changes after every 4 hours. So this is where I inserted all my information. We move on to the next slide. This is the demand ratio for 24 hours. As you can see there, you add under multiply, you add all those demands, those figures, and then you get like the results. As you can see there for your results, you see under time for a specific amount of time. So it actually did it in a 4 hour, because it changes after every 4 hours. So you can see after every 4 hours how much of demand you need, how much demand you actually have, and the average, and then you get that all there. and then you move on, and then this is your curve properties. This is what you use to actually determine to get the how many pumps do you need, or how much pump energy do you need. Then you put the information there and it calculates it for you. And then I ended up having to add 2 pumps from the previous run, from the previous information that I just explained. So this is where here I added my 2 pumps, I added all my information, and I did my run. And then after doing my run, I discovered that I had notifications, and then I checked all the notifications, and it's telling me that the pressure is on negative. So if your pressure is on negative, that means that the water won't run through your pipes. The design is wrong, so you have to do some altercations. And then I did my altercations. Yes, I did my altercations. I actually, pipe diameter were adjusted. I adjusted my pipe diameter since since the status was telling me the pressure is negative. I adjusted my pipe diameters, and then I did my run, and then my run was successful. As you can see there, I have a successful run. And here, these are the link results, the pipe results, where you see your pipe length, your pipe diameters, your flow, your velocities, your unit head loss, and your friction loss. And then in the status there, it says it's open, so the pipe is running smoothly. As you can see, all the results here, all the pipes are running now. And then you also go to your nodes, and then in all the nodes, you put your elevation, you get your elevations there. These are actually the results. You've already added your elevations, so it just gives you the head in all the nodes and the pressure in all the nodes. And those are more results for that. And then yeah, and then that's where then you come here to your system flow balance. So then after adding all that information and having a successful run, you get this graph. Actually, this graph tells you, as you can see, the red line is the water which is produced, is the produced, and then on the green line is the consumed. So as you know, when you're designing something, you must always have more produced than what is consumed, so you can actually have water running at all times. As you can see, the red line is always above the green line, so we have more flowing water. We have more flow on the produce, so you're producing more water than the water that is being consumed at all times. As you can see on the peak hours at the bottom there, if the consumption is at peak, then the flow, the produced water is also at peak. So in this way, you always have water running in your system, which shows your system, the design is successful. So if we move here, yeah, that's basically it. So I did the design according to every specs which we recommended and everything. So the 2 pumps were installed and everything was done accordingly. That's why we ended up being successful. As you can see there, my conclusion, the run was successful. And then these are the references that I used to help me and assist me get information for this project. And we are done. Thank you very much. Pleasure.